All right, so we're moving on to scatter plots and lines of best fit and interpreting rate of change. Okay, so all those things together. And the nice part is some of this actually pulls back to slope and the y-intercept and coming up with equations of the line and thinking about what things mean in terms of context. We are going to have to look at um, the labels on the graphs to try to figure out what our slope is talking about, okay? So to kind of get us going, let's just really quickly refresh how to find our slope, our y-intercept, and write our equation. So we know that the y-intercept, which is the b, falls on the y-axis. So that is where the line touches the y-axis. So in this case, that is a +2. And we also know that to find slope, I have to find two perfect points. And since this is a good point, I can use that point. So this is a positive slope. And I know it's positive because it's going up. Okay, that's important because we're going to come back to our positive slopes, our negative slopes, our zero slopes, and our undefined slopes today. And we have to find that second point. So let's follow this line up. So I keep going and I see that is not a good point because it's in the middle. And I see that here is a good point because it is on the grid. So I'm going to go ahead and make my slope triangle and I'm going to count. So this is a +1 because I'm going up and I'm moving to the right 2. So that is a +1/2. So my equation, if you remember, is y equals mx plus b. So that gives me a 1/2 x plus 2. Okay, 1/2 x plus 2. All right, let's take a look at a scatter plot. Okay, so this is a scatter plot. Remember that when we're talking about a scatter plot, that is a set of data that is a bunch of dots on an x and y axis, okay, on an x and y axis. And when we have a scatter plot, we actually are looking for types of relationships, okay, types of relationships, which goes to slope. So let's start with our relationship, okay? So I see that this data is moving in an upward direction. Okay, if I was to draw a line, and we're going to be drawing lines, I see that that would let me draw something in the upward direction. So that is a positive relationship, okay? Because that is a positive, if I was to draw a line, it would have a positive slope. The data is going up, okay? Now, when we write about the relationship, we actually work on using our labels from our x-axis and our y-axis to explain what is happening. So let's take a look at what our data is talking about. We're talking about restaurant sandwiches, okay? We're talking about number of fat grams versus the calories. Well, it makes sense that the higher the fat content in a sandwich, the higher the calories. Okay. The more fat, the higher the calories. So when I write my relationship, okay, I always start with my X value, my X label. Okay. So that means as the fat grams increase, and I'm using increase because it's going up, these numbers are getting bigger. The amount of blank, which is our Y, calories, oops, I guess I should spell that right. CAL are going to what? Well, what's happening to my calories? Well, they are also increasing. Okay. So if I see that both that I have a positive slope, that means that as the x increases, the y increases. Okay. The x increases, the y increases. Now there's a couple things we also have to pull back. We need to remember that the x-axis is the independent variable and the y-axis is the dependent variable, okay? Because when we describe what is happening, we always go from independent to dependent. So we start with x, go to y. X controls the y, okay? And a scatter plot allows us to estimate what is happening, okay? So it says, how many calories will I have if I have 17 fat grams? So I'm going to come over here and I'm going to find approximately 17 fat grams. And I'm going to come up and I'm going to see that I'm going to be in the range of about 400. There is a point right there that's at 400. Okay. Then it says, how many fat grams if I have 600 calories? Well, that's coming across on this side. So I'm going to come across and I'm going to see what I have here. And I see that I'm between 30 and 40 fat grams. Okay. I'm between 30 and 40 fat grams. Now, when I look at my line of best fit, and that's the part that we're going to be working on a lot this week, the line of best fit, okay, if you remember back to middle school, the line of best fit is where I can draw a line that splits the data in half, okay? So obviously that's not a very good line because it is not in the middle of the data, okay? This is not a very good line because that is not in the middle of the data. But if I draw a line that truly kind of splits the data, that's pretty close. Okay. That's pretty close. Half the data is on one side, half the data is on the other. And remember, when you draw this line, not a single point has to be on this line. It's just an estimate of where the best middle is. Okay. The best middle is. So if I use the line to kind of answer questions, okay, so 17 grams of fat, that's going to pull me right about 500 calories. And if I use the line to look at 600 calories and I come across, that puts me right about 30. Okay. So we're going to be using the line of best fit more often than not to actually estimate because that's going to be what we call our best guess. Okay. Our best guess, that line of best fit. So learning to draw that line of best fit is going to be important. Okay. The other thing we have to remember is domain and range. Now, domain is always our x's. Okay. Domain is our x's. So in this case, the domain is the fat. It's the fat grams. Range is going to be our y, which is our dependent variable, and that is going to be our calories. So we need both of those pieces as we move forward. So take a minute, make sure that you have your independent, dependent, domain, range. You know which one is which. You know how to tell positive, negative, and let's keep moving. All right, so again, we've got our scatter plot. And I'm going to go ahead and draw in my line of best fit. So we have talked a little bit about how to do that. But again, it has to split the data. So if I was to draw a line that was here, that does not split my data. Okay. So I want to try to think about if I was to lay a ruler across my data, where would that be? Okay. Now, your line may look different than my line because it is an estimate. Okay, it is an estimate. You just have to try to find the middle. Okay, try to find the middle and make a best guess. All right, now let's talk about our three types of relationships. There is a positive relationship, and that means that it is going up. It's going to be a positive slope if I was to draw a line of best fit. Okay, that means as x goes up, y goes up. Those are both increasing. Now, a negative relationship, that is a negative slope because it's going down. Okay, it's going down. And what's going to happen is one of them is getting bigger, the other one is getting smaller. Okay, one is getting bigger, the other one is getting smaller. And then a no relationship, that one kind of looks like somebody took a paintball gun and shot it all over the place. Okay, I know that, like on a positive one, that one's super easy to draw a line of best fit because everything's kind of heading in the same direction. This one is super easy to draw a line of best fit because it's going down. Our challenge is this one. How do you draw a line of best fit when it's kind of all over the place? Well, there's your line of best fit, and that is our zero slope. Okay. To split that data, I actually would end up going horizontal. There's half of it above it, half of it below it. There is no pattern. Okay. So positive is going up, negative is going down, and no relationship. It's just scattered all over the place. All right. So let's go ahead and we're going to label these points and we're going to graph them and try to figure out what kind of relationship it is. We're going to interpret the graph. We're going to come up with our domain and our range, label our axes, our axes. Okay. So our first point is 0, 22. So I'm going to put a point right there. And then we have 122.5, so that's kind of in the middle, and 223.5, that again is in the middle. 3 and 25, so that puts me there. 4 and 26, and I can already see that this is heading in an upwards pattern. 5, 27.5, and 6, 28.5, and 7, 29.5. Okay, so I can clearly see this is making a pretty nice line. Okay, so I know that it is a positive relationship because it is heading up. Okay, it is heading up. So I'm going to go ahead and draw in my line of best fit. Okay, draw in my line of best fit. And I am going to make sure and go through kind of what looks like the middle. All right. Now, based off of our line of best fit, we're going to try to come up with our M, our B, and our Y equals. Okay. So if I'm looking at my Y intercept, I see that I am not exactly on the 22. I'm actually kind of halfway in between. So I'm going to say that my B is 22.5. Okay. Now for slope, I'm still going to be looking for two good points. So I see that I have a pretty good point right here. And I see that I have a pretty good point right there. So I'm going to use these two values to draw my slope triangle. And then I'm going to count. And I see that I'm going up 1, 2, 3, 4, 5. And I'm going over 1, 2, 3, 4, 5, 6. Okay, so I'm going to say that my slope is 5 over 6, and I know that it is positive because I'm going up. So my equation is going to be y equals 5 over 6x plus 22.5. Okay, plus 22.5. Now, we are actually trying to estimate or predict the baby alligator's length next September because we are comparing months to inches, how big the baby alligator is. Okay. So to do that, we're actually going to substitute. Okay. So we know that we have our equation y equals 5 over 6x plus 22.5. Okay. And I am going to substitute in whatever value next September is going to be. Okay. Well, next September, let's see where we started. We started in September. So if I'm going to next September, so I have April, May, June, July, August, September. So this would be 8-month, 9-month, 10-month, 11-month, 12-month. So that would be 1 year after where we started. So that means that X is 12. Okay, so I have to substitute in 12. So I have 5 times 6 times my 12 plus 22.5. Okay. So let's use our calculator and let's do that. So 5 divided by 6, remember that is just division, times 12, and I'm going to add my starting point, which was 22.5. So my estimate is 32.5 inches. Okay, so I'm going to estimate that that is 32.5 inches is how long the alligator is going to be by month 12. Okay, now let's go ahead and I'm going to draw this out a little bit more. I'm going to make my line a little bigger. And let's take a look at where our line kind of shows up with our estimate. Okay, so we know that 12 would be right about here. Let's go up. Where did I end up at? That's pretty close to 33. So my estimate of 32.5 is probably not very far off with what my estimate on my line tells me. Okay. All right. So let's hit our domain. Our domain is our X value, which is our months. The range is our inches, which is our length of the alligator. Write that a little bit better. Length. Okay. And we have to describe or interpret. So when we do that, as blank increases, because we know that they're both going up, the blank increases because these are both going up. So what comes first? Well, months come first. So as the months increase or the months go by or as time passes, what's happening? The length increases. So the alligator's getting bigger. Okay, so I could say something as simple as months increase, the length of the alligator increases. I could also say as time passes, as the months go by, the alligator gets longer. Okay, so remember, we always start out with our X value and lead into our Y value. All right, now let's take a look at this one. So we're talking about bats, and we're a biologist studying the number of bats that will be living in a mine after 3 years. So this was 7 years ago, and now we're at this year, and now we have to figure out like what is it going to be in 3 more years. So let's go ahead and graph. So we have 0, 327. So I'm going to put that right about there. 1 and 306 again when we're estimating. So we're just going to make a best guess on our line. So 2, 299. That one I'm going to put right about there. 3 and 270. That one is about there. 4, 254. That's going to be pretty close to the 250. 6 and 215. That one looks like it's about there. And then, oops, 5 and 232. I lost that one. 7, 197. So that one's going to be pretty close to here. Okay, so the first thing that I notice is that this is going down. So I know that the relationship is negative. Okay, it is negative. And we also know that this is the years and this is the number of bats. So I can clearly look at this and be like, okay, so I see that as time is going by, the number of bats is decreasing. Okay, as time is going by, the number of bats is decreasing. So that's important because that's going to help us like interpret and describe what's happening in our graph. Okay, all right, let's try to come up with our line of best fit, and we'll use that to do some interpretation and some estimations. So I'm going to go ahead and try to split my data. That looks pretty good. Okay. Now, I am going to say that I'm starting at that point right there, which we said was 327. So I'm going to go ahead and call that my starting point. Now, 2 good points. Let's see. I see a pretty good point right here. And I see a pretty good point right there. Well, I know this is a negative slope because it's going down and we are not counting by ones. So I need to be pretty careful with what I'm doing. So I'm starting at 210. I'm going to 150. So that means these are actually dropping by 20. So 20, 40, 60. So that's a negative 60. And these are counting by 1. So 1, 2, 3, 4. So negative 60 over 4 is what I'm starting with a slope. Okay. Now we need to simplify that. So negative 60 divided by 4. If I simplify that fraction, I come up with negative 15 over 1. Okay. So my equation would be y equals negative 15 over 1, or just negative 15, plus 327. Okay, so we're going to use our equation to estimate how many bats there will be after 3 years. So that means that our x is 3. So here's our equation. Y equals negative 15x plus 327. And we're saying x is 3. Okay, So y equals negative 15 times our 3 plus 327. Negative 15 times 3, well, that's negative 45. And then we can use those two and get a total. So 327 minus 45, that's going to give me an approximate value of 282 bats 3 years from now. Okay, 282 bats. So let's take a look at where we were 3 years from our starting point. Okay, so if I take a look at year 3, where am I? Well, I'm about 270, 275. I'm between 270 and 290. That's not too bad of an estimate. Okay. Remember, it is an estimate. It is never going to match exactly with our data. All right. Our domain, that's our X value. So that is years. Our range, that is our number of bats. That is our Y value. Okay. And if I have to interpret and want to interpret my data, okay, that means that I am looking at what is increasing and what is decreasing. Well, my years I see are increasing. So as the years increase, the number of bats, remember that's my Y value, what's happening? They're not going up. The bats are going down. So the number of bats are decreasing. Okay, the number of bats are decreasing. And specifically, because I know that my slope is negative 15 over 1, this is the bats and this is the years. So I can estimate that we are actually decreasing by 15 bats every year. Okay, I'm decreasing by 15 bats every year based off of the estimated line of best fit that I came up with. All right, let's look at one more. Let's look at some surfing and let's figure out what's happening here. So we've got wave height of 3 and 24 and 6 and 61, 5 and 56, so someplace right in there, 1 and 15, and 4 and 35. So let's kind of look at what this is talking about. So this is talking about surfing, and it's talking about the wave height and the number of surfers. Well, it would make sense that the higher the waves, the bigger or the more people would be surfing. So it should be a positive relationship, okay? As the wave height increases, the number of surfers should increase. So let's go ahead and draw our line of best fit and see if we can split our data. So that looks pretty good. Okay, that looks pretty good. Now, keep in mind, not a single point has to be on the line. Okay, remember the line is an estimate. It splits the data. It may or may not have any points on the line. Okay, so we are estimating how many surfers might be at the beach if the waves were 2 feet high. So I'm going to go at my 2. I'm going to come across. I see I'm right here. I'm not quite at the 20. I'm a little bit higher. So there might be 21 surfers at the beach if I was at 20. Okay. If the wave height was 8, I can go all the way up here and be like, oh man, there's going to be a lot of surfers. That's going to be right around 72 to 75 surfers. Okay, so that line of best fit can be used to estimate. All right, so as the blank increases or decreases, the blank increases or decreases. Remember, we always start with our X. So as the wave height increases because it's going up, the number of surfers is going to increase. Okay, the number of surfers is going to increase. All right, so that should get you going on your homework today. Remember, the domain is the X, the range is the Y. Your slope, will determine what type of relationship it is. So if it's positive, it's going up, it's negative if it's going down. And as you are writing your relationship, remember to start with the X and lead to the Y. If you have more questions, go ahead and watch some of the videos in the red folder on scatter plots and lines of best fit. That should help you out.